What is up, everybody? Mark on the mic here. It is time to step into the light. And no, nobody's dying or nobody's dead. We're talking about light transmission. And to help me do that today, I have my good friend, Mr. Ryan Muckenhirn, and also my good friend, Mr. Rob Morell from the Product Development Department. Rob, this is not your first time on the podcast.
No, it's always a great day when I get to chat with you guys, and especially in podcast form. I always look forward to it, so thanks for having me back.
We were just chatting downstairs in regular form about various things and cartridges and stuff that goings on here, and now we're in podcast form.
Yeah. I don't know if we'll somehow find a way of how to fix your group size on this podcast, but maybe we can find a way to make it happen.
We're gonna get there.
Yeah.
Maybe there's a pill for that. I don't know.
Maybe.
Okay, light transmission. Rob, I see that you have a printout.
I do.
As do I. I've got some questions here.
No pivot chart this time, though, or no pivot table.
Okay. I'm not...
Taking a step back.
I didn't expect this is a 10-minute talk.
Sure.
Ish. This is a big ish on this one.
Yep.
We'll be upfront about that.
Should we get an over-under in the comments of how long this... Well, I suppose they're going to know as soon as they start watching it.
I think they might.
Because the timestamp's on there. Never mind.
See the title and be like, what were they thinking? That's what you said when you came in here, Ryan.
I did say, I love how you made this a 10-minute talk and then went...
Optics. That's what we work with here. Light transmission, a feature that's often talked about.
Yeah.
Feature, phenomena, something that an optic, I guess, expresses in a certain way. Talked about a lot. Something people look at, something people care about. I think maybe not always understood.
Sure, that's fair.
I'd say more often than not, misunderstood. Definitely.
Yeah.
In fact, Bill had a question today from a customer on the phone asking about light transmission, specifically figures associated with. What percentage?
Oh, interesting.
Yes. Because there are some folks out in the industry that will put a number on there. They'll hang a number on there. And they were curious why we do not.
Yeah. Well, I think the reason that we don't is because it could be a little misleading if we just kind of put broad numbers on things.
Sure.
So, if you think about light transmission, really, that's how much of the light from the target or from the scene is coming into and through the optic before it makes it to your eye. So if you're looking through a tube with no lenses, you would have 100% light transmission. That's kind of what we joke when we do like a 3D print of a scope body or a binocular body and we're able to look right through it.
I'm glad we're doing this first because that is my first question. What is light transmission?
Yeah.
What are we talking about here?
It's a very literal definition. It's how much light is transmitted through the optical design that ultimately reaches your eye. Back to your question of why don't we advertise a number, there's really no standard.
Sure. Because are we talking?
I should say there's no industry standard.
Sure.
And depending on how the optical system is designed and depending on what wavelength of visible light you're looking at, you might have something that's 98% light transmission, or you might have something that's 85% light transmission. So, you could take an average, you could take a median, you could take a standard deviation, you could do a weighted average based on wavelength, you could do a variety of different things, but because there's really no industry standard, at least I personally think it's a little misleading to just throw a number on there. And we could try to, I guess, if there's really interest to it, we could try to generate a standard, but that would be getting kind of everybody together and trying to agree upon how we're going to measure or advertise this thing. So I think there is an ISO standard method, though. Based on that being said, I don't think everybody's using that.
Sure.
So, okay.
Sure.
And that was my question because, like Ryan said, you see that quoted sometimes.
Yeah.
Oftentimes a pretty spicy number.
Yeah.
And
holy smokes, yeah,
that was my question. Like, is there an industry standard is everybody doing that the same way?
Yeah.
And
No,
sounds like
I don't.
Mostly not.
I don't think so. So there is an ISO standard for doing it again, but I don't think everybody's kind of following it, and that involves basically having a system, establishing a baseline with that system, then putting the optical design and doing a measurement thereafter, and some other kind of specific kind of measurement scenarios to do with that. So it might just be that it's really pretty involved to be able to do that, and perhaps with the optical design on paper that somebody has together, or a coatings, basically a coatings diagram as part of the optical design, you might be able to surmise what the light transmission would be, and then just go off of that.
Okay.
But I don't know. I mean, I can't speak for other companies. I don't know what they're doing on
sure.
that, so
Sure. What factors in an optical system, maybe the answer is all of them, translate to light transmission,
Mm-hmm.
and maybe are they the same for like a rifle scope to a binocular that has two barrels, or is this just happening, twice times in a binocular? What's going on there? What's factoring into that light reaching your eye?
Yeah, so it's going to be largely similar regardless of what the optical design is. If you kind of really boil it down, as light's going through some medium, whether it's air or really as it pertains to what we're talking about here, glass.
Mm-hmm.
Glass is going to, as it's going through that glass, there's going to be transmission, there's going to be absorption, and there's going to be reflection. Essentially,
Mm-hmm.
that's happening with that light. So essentially, the light that's not absorbed or reflected through the lens train as it goes into, for those watching, into the objective bell and out of the last eyepiece lens. Mm-hmm. So that's the total light that goes through is what's transmitted. You're going to have losses throughout that system, and that's going to vary depending on the lens design, number of lenses, lens material selected, and coatings that are used on the different lens surfaces as well. And then, with binoculars, you've got prisms that are involved as well. So think of a prism. It's not a great analogy, but it's similar to a lens in that you've got, instead of transmitting light all the time, you're also transmitting and reflecting light, but you're reflecting much more than you would be in a lens. A lens is a much more transmissive element of the optical design, whereas a prism, you're reflecting light more in that design. So, but in any event, you got some glass element and you've got coatings, and the material of the glass on the coatings are what affects the light transmission.
Gotcha. Another stat that we see, oftentimes, I guess, correlated to light transmission is exit pupil.
Yeah.
Now, you just talked a lot about it, an optical system as a whole, the components that are making up that optical system, prisms, lenses, things like that. They're all sorts of different prisms and lenses. But when you calculate exit pupil, like we'll take this binocular,
Mm-hmm.
or we'll say, I like easy math, we'll say a 10 by 50 binocular.
Sure.
It's that objective diameter of 50
Yep.
divided by 10 gives you your exit pupil. Well, we have many series of binoculars that have a 10 by 50 within that series
Mm-hmm.
that are going to give you that same exit pupil number.
That's right.
But they're made with different things.
Yeah.
So what can a person do, or what's going on that maybe I'm not articulating this exactly
I know what you're trying to
want.
say, Mark. What you're getting at is exit pupil alone does not give you the light transmission number that you may be looking for. In that, a 10 by 50 from one of our categories may not be as bright in low light as another. Right?
Exactly. But you go, well, it's a 10 by 50.
Yeah, and the exit pupil yielded is 5 millimeters, so doesn't that stand to reason that, in fact, it should be? But because of the makeup or the optical design, so front lens to back lens and everything in between, one is likely to yield a brighter, more brilliant image than the other.
That's right. And so that's going to go back to the optical design,
Sure.
the lens materials that were selected, the types of coatings that were selected, are what's going to give you the difference in brightness. So back to your original question, how does exit pupil, factor into brightness? It doesn't. So if you think about a binocular, we're talking about binoculars, it's a pair of 15 by 56 Diamondback HDs. On the front end for a binocular, the larger the objective lens, the larger the light gathering potential. Then the rest of the optical design is going to dictate how much of that light is transmitted through to your eye. But the fact that the exit pupil is larger doesn't mean that more light is transmitted. That basically just equates to where can your eye be relative to the exact optical center for you to still be like in the eye box of the binocular. So you hear that a lot on rifle scopes, where if you have a larger eye box or a larger exit pupil, that's desirable because your head position's a little bit more forgiving when you're on the gun behind the scope. Again, it doesn't make the image any brighter. It just gives you more positional forgiveness on where your head can be and still have that full field of view, if that makes sense. So really the larger the objective lens, the more light gathering potential you have, but the larger the exit pupil doesn't necessarily mean you have more light that's come through the system. Does that make sense?
Yeah.
But it could be used as a good reference or a way to get your bearings on it. If you're looking at, case in point, Viper 10x42 or a Viper 10x50. We would expect the Viper 10x50 to have a brighter image.
Correct. Because the objective lens is a larger objective. The objective lens is larger. I'm sorry. But if we had, for example, an 8x50,
yep,
or we have an 8x42 and a 10x42 configuration, you might think, oh, the exit pupil's larger on the 8x42. It should therefore be brighter. That's not necessarily the case.
Right.
It depends. There's other elements that go into the optical design, but in that case, you'd expect the image brightness to be the same. You would have different field of view on the 8x42 compared to the 10x42 because the magnification's different. And then your eye box or your exit pupil would also be larger on the 8x42. So you'd have a little bit more positional forgiveness of where the binocular is on your face and the IPD adjustment and like those sorts of things.
Sure.
That make sense?
Yes.
Gotcha. We often hear, is that good glass?
Mm-hmm.
Like what kind of glass? And I think when people they're often actually referring to the lenses, at least, how they're thinking about it.
I hear it all the time.
What determines quotation mark quality glass? And then along with that, how does quality glass translate to light transmission? Like what is that glass doing that it might be giving you better light transmission?
Yeah. So I think it goes back to the optical design. So when I hear that used a lot, that term used, it's like, oh, that's got great glass, or that's certain level glass, that's razor glass, or that's alpha class glass, or whatever.
Or it has this certain type of glass.
Yep.
Yeah.
And so, I think we've talked about this before. If you think of an optical design, it's a recipe, effectively. And Christian, one of our optical engineers, did a funny kind of video of like just putting a bunch of stuff in a bowl, and then I think that was for our like department video a while back.
It was very good.
Anyways, it's engineering humor for you at its finest. Why I go back to the recipe analogy is it's a useful one, I think, in that you could have premium ingredients, have no idea how to bake a cake, and have a terrible cake. Conversely, you could be an excellent baker and use not the best quality ingredients, but still have a pretty darn good cake. So you got to kind of use them both together. So, to your comment on using specific types of glass, well, that maybe allows you to unlock a little bit more performance if you know what you're doing with it. But if you're just taking it and you're throwing it into poor optical design, you're not going to have the good optical experience at the end of the day. So when people say good glass, to me, that's all encompassing of like, what is the total optical experience? Light transmission is certainly part of it. If you, and especially in low light, like a lot of hunting, like whitetail hunting around here, when it's either going to be first or last light, you really want to have as bright of an image as possible because you want to be able to see what you're hunting. If you're doing, you're hunting out west in the middle of the day, maybe the light transmission isn't as critical of a factor, and it's more resolution or contrast or field of view or whatever might be important for your specific kind of application. And that's why you see us offer a whole bunch of different configurations for binoculars or for rifle scopes for that matter, depending on how far people want to kind of get into it. So, to answer your question maybe a little bit more is it's the optical design, it's the lenses, the lens materials, the coatings that are all put together in concert to create the optical system. And that's kind of, to me, what makes good glass.
And I think, to speak from very recent experience on this too, there's an often held, I'm not going to call it a misunderstanding, but some folks think that a certain type of glass, as you had mentioned, like the optic will only be good if it utilizes this glass,
right,
from this famous glass manufacturer. And as Rob had alluded to, maybe, if it's done correctly. And something that really woke me up to this, because I was always under that, when I was coming up in the retail space and whatever, you had an assumption that, okay, brand X, Y, or Z utilized this very famous type of glass, that was the fountain where everybody came to drink from if they wanted to build a premium optic, and that is ultimately what you ended up with.
Yeah.
And then I learned a lot about, and this was from Christian, the optimization of optical design, where sometimes that actually is not the best piece to use there for a given thing. And if you change that and you have that optical design really down pat, you actually end up with a better product, even though it doesn't contain that one special thing. And I was just at a trade show last weekend, and a gentleman come up and asked me if we used this very famous glass. And when I responded, well, no, but I'm curious, what got you to that questioning? And he's like, well, they're only good if you use this type of glass. And then we had a conversation about optical design, and I think it made quite a bit of sense to him. And like I said, I was there fairly recently, maybe a decade and a half ago, that I thought it had to be, you had to use those, as you said, premium ingredients in that cake.
Yeah.
But again, if you don't know what temperature to bake it at, or when to
the
put
wrong
the egg
proportions,
in.
or yeah.
I mean, I could, have a Wagyu beefsteak and then cook it well done, and boy, that just doesn't do anybody.
Got a Wagyu hockey puck at the end of the day. But I mean, you think about it, and this is what we do as our job every day, and we love doing it. So we like nerding out and getting into the details. You got some guy that's, I don't know, building houses or doing whatever. It's like they don't have maybe time or interest to dive into that. Yeah. So, it's important for me to think about that too, and that, well, yeah, we kind of know all these, but we know all the inside baseball stuff of what's going on to actually make the thing. Most people or may not, and maybe they have no interest in either.
Sure.
So it's kind of something for us to keep in mind as we're designing products too.
Something is fascinating to me about optics, and one being behind the curtain as well as also being responsible for helping open the curtain and then show the show, is how good optics have gotten in the past. I've been retailing or in this outdoor space now for 20 years. And when I look at what was an exceptional optical design 20 years ago versus what is by some standards entry level today, and how close they have gotten and how the bar has been moved and moved and moved.
Yep.
And that's coming, of course, from the way that optical grade glass is processed, like modern manufacturing has got really good, but also being able to really nail down that optical design and the layout of it. And there's some really standout examples that I still own in my gun safe that at a time were like Paramount products. They're as good as they got. And then today I can look at an optic that costs considerably less and compare the two, and I hold this thing in my hand that I used to think was sliced bread. And
because it was.
Yeah, at the time. And then it's like, wow, we have evolved as a species, and for the better, with respect to optics anyways.
Yeah, and it's been interesting. Well,
some other stuff you're not so sure.
It was released optics. And 100% agree with you there. I think some more specifics on that, just with the wider adoption of automated manufacturing and assembly. Sure. That helps a lot with the consistency. So then you can have optical designs that have tighter tolerances because, well, you can assemble them more repeatably, or you can machine the components to be more consistent. I think the other big thing that we've seen is just the improvements in lens coatings. So one of the things that gets brought up is like fully, multi-coated or anti-reflective and those sorts of things. And years ago, just having an anti-reflective coating was a big deal, and like having fully multi-coated was a big deal, and it still is because it allows you to do, it allows you to leverage keeping more of that light through the optical system. But now, I mean, like the lens coatings are way more broadly available, I believe, and so when you have the ability of doing these nicer coatings without adding a tremendous more additional cost. Again, that goes back to the automation and the ability of really being able to dial in these coatings and do it very consistently. So that's been another thing that's allowed us to improve on optical designs.
And certainly manufacturing practices that didn't exist 2 decades ago.
Yeah, sure.
And that's what's neat for me to see that, and all of a sudden we discover a new way to do something that just simply hasn't been done. And you're like, holy smokes, that's tangible. Like that brings something really meaningful to the table. And 30 years ago, that process, those chemicals, the entire thing was a pipe dream.
Right, right. Rob, back in, when I first started in the industry and learning about optics, and that would be pre my Vortex days, but you were just talking about coatings, and I feel like there was coated, fully coated, and then fully multi-coated.
Sure.
Today, I feel like I'm not aware of an optic, and correct me if I'm wrong, in the Vortex lineup that's not fully multi-coated.
Correct. And that kind of gets back to what I was saying. And let me just caveat that there might be something there somewhere, right? We've got products that have been around for many years, and we're always working on updating stuff. We just launched a new Viper lineup last month or 2 months ago, I believe it was. So yes, I think the vast majority of stuff that we're coming out with now, each lens surface is going to be fully multi-coated. And basically, like I was saying earlier, whereas before you had just a general broadband anti-reflective coating, and then maybe you went to, or what did you call it, the broad coating, or?
I feel like it was coated, which that'd be like at least one air-to-glass surface has a coating.
Yep.
And then fully coated would be like all air-to-glass surfaces have at least a coating.
An AR coating.
And then fully multi-coated is like all air-to-glass surfaces have multiple coatings.
Yep. And I think, okay, so like if you think of just a normal anti-reflective coating, that's
the way
like,
I understand it, by the way.
Yeah, that'd be like a magnesium fluoride coating as an example. And so this is a little nerdy, but if you think of light that's coming through, like I was saying, you've got transmission, absorption, and reflection essentially in each glass element. So the anti-reflective coating is basically through, I think it's destructive interference. The light that would have reflected out of the system then essentially kind of gets bounced back in. And if you think of light, we'll use this analogy because I think it'll be useful, as like a law of conservation of energy, law of conservation of light. If light is coming in and it is either absorbed, reflected, or transmitted, and you're reflecting less of it, it needs to either be absorbed or transmitted more. So that those anti-reflective coatings allow for light to be not reflected out of the system in an undesirable way, but rather transmitted through the system to your eye. So before, with that magnesium fluoride coating, that was kind of what was widely available. And now you've gotten into more sophisticated coatings that have gotten really dialed in, that are kind of, they're different formulations that fit into the fully multi-coated realm that allow you to have even less light leave or be reflected out of the system in an undesirable direction. A little bit of a tangent there, but that's kind of what's going on with the anti-reflective or AR coatings, and difference between that and maybe fully multi-coated.
Okay. Gotcha. I hear these, so we've been talking about light transmission. Then I also often hear about Twilight Factor.
Mm-hmm.
How are those things working in tandem, in conjunction? What does that mean to a person who's looking at a binocular or looking through a binocular?
So,
Ryan?
I'm just wondering why you brought Twilight Factor to the table.
Oh, I was curious.
I'm not going to say it's a dangerous thing because it's valid. But we had Mike talk about Twilight Factor.
I know.
Yeah.
Mike McDowell.
Yeah. And it can be an important indicator as to what you're going to end up with from an image, but it doesn't tell the whole story. Twilight Factor alone, and I think Mike would agree with this, should not be the basis of selection or basis for selection for a binocular. Because you could have a higher Twilight Factor in a given optical design, but actually end up with an image that is not going to be as brilliant to look through, as high of a resolution to look through.
Yeah.
It's almost like, I'm not going to say it's a dated.
It's another perhaps useful way of looking at potential light gathering capability, but does not translate, similar to what I was talking about with objective lens.
Okay.
You've got more light gathering capability or potential, but everything that's going on from that first lens to the last lens really is going to dictate more of what the total light transmission is. Mm-hmm. So you might be able to start off with a higher potential light gathering capability, but then end up with a duller image at the end because of how the optical design was designed, or the certain things that were selected in that. So it's not that alone cannot be something that you can understand what the light transmission is going to be. It's really how much light are you starting with, and that's what you can use Twilight Factor as an effective tool for understanding how much light you can potentially gather at the front end of it.
Gotcha. Ryan, any questions you have or anything you have to add?
Oh, to talk about glass, go back a little bit. Glass density. So if I had a lower density glass next to a higher density glass, we should expect that the glass that is in fact higher density should allow light to pass through less impeded, or how did you say, absorbed, reflected, or transmitted?
Yeah, should transmit more.
Right.
Yep.
And when we're referring to density, oftentimes, and correct me if this is the right thing to say or not, if you were to cross-section that lens and put it under a microscope and look at it, a high-density lens would have a lower frequency of inclusion or bubbles compared to a lower-density lens in which you would cross-section it, look at it, and it would appear porous.
Like a sponge, maybe.
Yeah. Those inclusions or bubbles are surfaces in which light can be reflected incorrectly or absorbed and not allowed to transmit through the system. And so when we get asked about high-density glass, what is that? It is literally the frequency and size reduced in both respective fields of those inclusions in the lens.
Yeah, that's how I understand it to be as well. And so, we were talking about coatings before. You can't coat all those little inclusions, obviously on the inside of the lens. So, and also it'd be very difficult to figure out how to design for that as well. So, I mean, really, you've got that as an element of the glass type that Christian or one of the other optical engineers would be considering as he's doing his optical design, right? Like, where should I use the expensive glass? Where should I use expensive glass through the whole thing and make it like a super expensive, rifle scope? Maybe, but also we got to listen to what the customers in the market are asking for. So that's always and this is the case with product development pretty much across the board. It's like, well, what's the right combination of things to make the product that's most exciting and attractive for the customer at a given price point or a given application or whatever the case might be. But yeah, that's how I understand it. Back to lens density.
When a person hears like HD glass or ED glass, should they be kind of thinking of those things the same way then?
Yeah, I think so. Again, it's kind of one of those things where in a vacuum probably doesn't do, in a vacuum it sounds great. You have to look at it comprehensively as the entire system. So, but I think when we use those as a marketing term, it's saying like, well, we use this and we used it properly in the entire optical design. So, you can expect this to be a better optical system than perhaps one that isn't employing that. But then, we also look at the kind of the different product families that we've got. And I think internally we kind of have an expectation of what the optical quality of a Razor product versus a Viper product would be and that sort of thing too. But we're always trying to push the envelope on what that next generation Razor or Viper or Diamondback or Crossfire, whatever the product family is going to be. So, I don't know if hopefully that answered your question a little bit.
Yeah, for sure. Another thing I was curious about, the human eye, just very interesting, right? If a person is looking through two binoculars and they're trying to maybe grade them based on light transmission, what delta in difference between the two would there have to be for the person to be like, yep, this one is definitely better. I can tell a difference.
Yeah. So the human eye, I believe, can detect a difference in brightness on I think I looked this up. I think it's a logarithmic scale. So it's not like if the optical design is 5% brighter, your eye's not going to be generally sensitive enough to detect that difference. It would need to be like 100 times brighter or 10 times brighter or something like that. I think log is on 100 or on a 10 scale, excuse me. So it would need to be considerably brighter for you to be able to perceive a difference. And then there's other things too that might influence your perceived brightness. And I think that's the other thing too, is if you think about how light transmission is measured, is it how it's measured by the human eye or how it's measured by a camera sensor or how it's measured by some other sort of measurement device? So there are other factors that can go into whatever the perceived brightness would be of binocular A and binocular B as you're looking at them side by side. And sometimes those are manifested in worse contrast or better contrast. It might appear brighter. Resolution might have an impact on perceived brightness. It kind of goes back to the overall kind of optical experience, and light transmission being an element of that. But alone, I mean, you could have an extremely poor resolving optical system that's extremely bright, and it's unuseful. So, it's something to consider as part of the optic selection, but it's not the entire picture.
Yeah.
So, but that's why we have Ryan and his wonderful team of folks to answer questions as people have them, when they're trying to figure out what optic of ours to buy or what's going to be great for their next hunt or whatever else.
What's really fun about what we do here is you guys let us play with them when we get into the early sample phase, and then we all meet at the secret spot and we start evaluating optics, and sometimes we'll be out there for hours at a time, or we go out there intentionally at certain times of day or evening or night or whatever we're doing, and we argue over who's seeing what. And then we discredit our peers because, you're too old, your eyes don't work, or these kinds of things. But it's really fascinating.
That's my favorite part.
Yeah. It's really fascinating, though, how an individual has a perception and can, I guess, qualify the perception with, here's what I see or here's what I don't see. And the next person does not see the same thing. Some people, either they don't notice it or their eye is not sensitive enough to pick it up, or it doesn't bother them. Like I'm that way with chromatic aberration, and that was the worst thing that ever happened to me. I think it was either Sam or Dave showed
Somebody
me.
telling you about it?
Yeah, and this was like day 7 at Vortex. And
friends don't show their friends CA.
Yeah, so after that moment, like it became I can't reconcile it.
Can't unsee it.
And so when we're in the eval phase, if I see it, it's like I can't. And I throw my hands up and leave. But
on the sales floor, pointing that out though, like that's the ultimate upsell. Let me point this out. Now, do you see? Oh,
yeah, and that's it. That's all. That's a good point. It is kind of fun to do. It is really neat to do. And then when you play ball with somebody like McDowell, for instance, who's been looking at optics professionally for 25 years, he can pick up the smallest, minutest detail in an image, and then he'll hand me a sample and he say, "Okay, find it." And then you sit there and I don't know, I throw this out, throw that out. No. And then he's like, "Oh, here's it." And then you see it and you can't unsee it. It's kind of neat. But the individual and how their eyes work, how their brain perceives, and I guess what they're looking for, or rather what they're not, could completely derail the conversation. And if somebody's looking through it and they don't see either a meritable trait or a flaw, it could dictate a completely different outcome with the seller perception of that product. And on to you, Mark.
Did we miss anything? I'm out of questions. That was it.
I want to talk about this at large. Something I get a lot. We're kind of talking about what is the difference between, and I'll use rifle scopes for an example, where I was just at this trade show. They put a heavy precedence on 50 millimeter rifle scopes. They got to have the 50 millimeter
objective lens.
Yes. Because they're hunting in heavy timber, often low light conditions, often crummy weather, and at those times, which deer are often moving morning and evening. And so in the new Viper HD line that we released, one of the more outstanding examples that I'm in love with is the 2-10 with a smaller 42 millimeter objective. And it was, I would say, somewhat of an uphill challenge for me to talk to people about inherent optical qualities that lead to a brilliant image in varying light conditions, but with an objective diameter smaller than 50 millimeters and significantly smaller. I mean, 42, and that still sticks to this day. And it's not invalid in that if we had a 2-10 by 50 and we had a 2-10 by 42, there would be an expectation that the 50 would have a higher potential.
Yeah.
The reality is, though, and we don't come to these figures and numbers haphazardly. We're not just sitting there and Rob is saying, we're going to make it a 42 just because. either in modeling or in actual physical samples, we can see or absolutely see that, going to that larger objective had a negative consequence to the image.
Yep.
At some or many different points. And so when you're looking at rifle scopes, and I think this applies for everybody who's producing a rifle scope, I think that it should be a given that the optical engineers that are putting these together and bringing them to market are doing so for the best experience, despite what that figure hung on the end of that rifle scope's magnification and objective denotation is. 50 doesn't always mean better. And, size doesn't matter, I suppose, in optics. I'll come back to that again.
Yeah. Well, and the thing, too, to keep in mind is, so if you go from a 42 millimeter to a 50 millimeter, now you have what's called a faster like optical design. And so because that light is coming in at a steeper angle, and then you need to correct for it to have it go through the rest of the optical design the way that you want it to have the image come out at the end. Oftentimes with that wider or that larger objective lens, you have to do other things to correct for that. Otherwise, there'll be other aberrations that present themselves. May it be CA, or maybe it's coma, or some lack of contrast. You've got other things that are happening as a byproduct if you did nothing else of just going to a larger objective lens. So yes, you do have greater light gathering potential up front, but then the question is, okay, well, what are you going to do after that?
Yeah.
And so maybe, if it's important for us to have low CA, or it's important for us to have high resolution and contrast, or whatever the combination of things might be, perhaps then that the incremental improvement in brightness or perceived light transmission at the end is within that log scale where you won't be able to tell.
Yeah.
And so now we've gone through this whole exercise of designing the optic differently to be able to do that, which is effectively for kind of a marketing purpose of a perception of what the perception of the scope is actually is
what it's
brighter.
capable of. Yeah.
But it's a tough thing, and kind of like what I was talking about earlier. If somebody doesn't want to learn all of that stuff, I can certainly understand. It's like, well, I got a bigger funnel, I can catch more water, right?
Yep.
So it's a logical thing to think, and it's based in truth. I mean,
right.
You've got the ability of gathering more light. It's how efficiently are you able to transmit that light through the optical system.
And it is crazy to know, like, to take a 40 millimeter example and a 50 millimeter example in the same family, so same components utilized, obviously slightly different optical design because there's dimensional differences between them, but to set them side by side and to wait for the last waning seconds of light, I believe that the perception may be that one of them, you're going to pull that rifle up, or you're going to pull that binocular up, or that spotting scope, you're going to look through it and you're going to see everything in great detail. The other, you're going to look through it and see nothing but black.
Mm-hmm.
And it's simply not the case. And I did this actually with a customer in the showroom. What's nice about having our showroom in the winter months is it gets dark pretty soon.
Sure.
During business hours. And this gentleman had come in and he was hung between a 44 millimeter system and a 50 millimeter system in the same family. His concern, definitely low light performance. And I'm explaining to him, like, it's not maybe what you think it is. I'm talking about, as we go to that larger lens, what trade-offs you're going to have, and the biggest tangible probably being like the ability to resolve, I suppose. We expect the smaller lens to have maybe a little bit better resolution. And he just wasn't buying it. He was definitely sold on the fact that the larger lens equates to a brighter image, and that his hunt will be either made or lost based on that. And we set him up on tripods, and we're out there in our bundled up gear because it's like January, and it's like 30 minutes past legal shooting light, and it's just gray. And he's looking through one and he's looking through the other, and he's like, well, I don't see the difference yet. And then the clock keeps ticking out, and he's like, I still don't see the difference. They're about the same. And I'm like, and we couldn't have shot that deer 40 minutes ago. And then pretty soon, like, one blinks out and then the other. I mean, matter of seconds difference, and that the eye could pick up that difference. And probably the power of suggestion more than anything, because it's not so significant that the wheels just fall off that vehicle when you're doing that. So it's neat, because again, that was something when I started retailing optics, Bigger objective means brighter every time. And these days, my selection goes to better optic means better image. And there's an asterisk on behind that too. But it's not the physical characteristic of the optic that dictates that.
Well, and depending on the optic and the application, a larger objective can be a benefit. That's why that optic is designed that way. But I'm really glad you brought that up, Ryan, because I think there are a lot of folks, I'd say particularly in the rifle scope category, that they're going through, they're looking through the catalog or on the website, and that 2-10 immediately discarded.
Absolutely. Not
even in the conversation because it's got a 42, not a 50, or even an optic between a 44 and a 50. Nope, you're out. I know I don't want you. And it's like, man, you could be missing out on the absolute perfect rifle scope for what you are doing.
Yeah, absolutely.
And that makes me sad.
Oh yeah. But that's the tough part of convention. And for a time, that was it. The only way you could get it brighter, I suppose, was to go bigger.
Well, and the other thing too that we're not really talking about, we're talking about all the optical trade-offs. There's also mechanical trade-offs.
Sure.
So you go to a 50 millimeter objective. We'll just look at a binocular as an example. You got a 10x42, 10x50. 50 is going to be heavier.
Yeah.
Might be longer, depending on what we decide to do with the basically the objective lens assembly. So you've got those things to contend with as well. So you might say, well, Rob, just take that 2-10x40 and turn it into a 2-10x50 and just sell a pile of them. Well, maybe, but then how much extra? If that adds an extra 6 ounces, is that something that people would want? Maybe not. You got a larger objective bell. You can't mount it as low to the rifle, so you got a larger bore offset. Maybe you can't get as good of a cheek weld now. There are these other things to kind of consider, and which we haven't really touched on. It's been mainly in the optical space, which is fine, but there's other things that we kind of have to think about as it goes into the entire product design as well.
Mm-hmm. And then also, does it give meaningful improvement to that system, or is it a means to satiate because we hung a number on there?
Mm-hmm.
And I'm super proud to say, when we come out with an optic like the 2-10x42 or a 3-15 by 44 as opposed to a 50, it was intentional, and it was an optimization, but also maximization of so many other things, optical and mechanical included, to end up with that package. So we have your best interest in mind.
Mm-hmm.
We do.
Well, and many of us here really enjoy hunting and shooting. So it's like, well, what's the most badass optic that we can make that we would love to use too? And you can't get too hung up on that, because you got to really understand the customer. We're customers, but we're a cross section of the customer, right?
Mm-hmm.
So, but I think that passion kind of helps drive the desire to design something really, really good versus just mail it in and make it a spec monster and actually not translate into anything useful.
I've never heard that, a spec monster.
Yeah.
That's awesome.
All right. Well, I'll see about using that more.
That thing's a total spec monster.
Well, maybe you have to TM that one. We'll get legal on that.
What we say on the podcast here is patent pending.
Patent pending.
Yeah.
I don't think it works that way, but it sounds good.
I mean, you don't think it does, but prove us wrong.
All right.
So, Rob, we covered a lot of really important ground here.
Yeah.
I'd say particularly spec monsters. But, we've talked about a lot of features, some of the science behind it. And then ultimately, though, when we're talking about the complexities of optical systems, what would you say? You'd say the answer is?
Well, Christian will love this one. The answer is it depends.
We got him, people.
I knew I could bait him into it. Awesome. Well, thank you guys. Thanks everybody for listening. Hopefully you learned a little bit about light transmission. I know I always do, even though it's like I get a refresher course, even when we cover bits and pieces of these throughout different podcasts. Rob, always fun having you here. Looking forward to the next one. I don't know what it is, but we'll make it up and we'll come up here again and record.
Looking forward to it.
All right.
Thanks, guys.
Thanks, everybody.
See ya.
Bye.